Here we are on section 7.1. We're starting out. We're going to be doing two sections today. They're relatively quick sections. So let's start with a little bit of a review. This is review from chapter 6. And in a parallelogram, we know that consecutive angles have to be supplementary. So I'm going to take 4y plus 8y gives me 12y, and 5 and negative 5 gives me 0. They have to be supplementary, so they're equal to 180. Dividing by 12 gives me 15. So y is equal to 15, but that doesn't tell me what the measure of each angle is. If I put it in here, I get 4 times 15 is 60 plus 5. This is a 65-degree angle. 8 times 15 gives me 120 minus 5 is 115. And we know that opposite angles are congruent to each other. So this one down here is 65 and this one is 115. So let's talk about taking notes. All of chapter 7 is similarity, so we're going to be doing a lot of proportions. First, let's talk about if the Twins won 5 of 8 games against the Tigers. We want to know what the ratio of wins to losses. Well, when they played 8 games and they won 5, they lost 3. So wins to losses would be a 5 to 3 ratio. What is the ratios of losses to wins? 3 to 8, because losses is said first, it goes on top. Wins is said second, it goes on the bottom. What is the ratio of losses to games played? And that would be 3 to 8. Simplifying ratios. Now, ratios don't have labels on it because there's labels both on top and the bottom. We cross those out. Dividing top and bottom by 3 gives me 5 over 8. Same thing here, but we have to change these into the same units before we can get rid of the units. So I know that 1 meter is to 2,000 meters because there's 1,000 meters in a kilometer. And now I can cross off the meters, and my ratio is 1 to 2,000. An extended ratio, we can have more than 2 numbers being in a ratio. For instance, we have the measures of the angles of this triangle are in the extended ratio of 3 to 4 to 8. Find the measure of each. So if we're in the ratio of 3 to 4 to 8, we could just do some guessing and checking and say, hey, I'm going to multiply all of them by 2, multiply all of them by 3, and we could keep going until we got them to add up to the sum of 180. Or, if we were so inclined, we could say 3 times something plus 4 times this something plus 8 times that same something has to equal 180. Simplifying that down, I get 15x equals 180. And if I recall from the last problem, 12 times 15 equals 180. That doesn't tell me what the angles are. That tells me what I'm going to multiply each of the numbers in the ratio by. So I know the actual angles are 3 times 12, 4 times 12, and 8 times 12, which gives me 96. And if we check those, they add up to 180. In here, first thing that we need to notice is that the notation for similarity is just the squiggle line. We take the equal out of it from the congruence. So it's just triangle ABC is similar to triangle DEF, and the corresponding sides of the ratio are in the ratio of 1 to 2. Solve for x and y. So again, if we go back to our solving for congruence, we know that we have 8 is to, in the ratio, BC, this side here, would be to EF, because they're the second two letters. So if I'm looking for EF, so 8 is to EF, and they tell us that the ratio is going to be 1 to 2. So we get the ratio is 16 equals EF, or EF times 1. The same is true for finding the Y value. We're going to say that AB is to DE, so I'm going to say AB is to DE as 1 is to 2, because they're telling us the ratio here. This is part of our proportion when we set it up, and I get Y equals 34. Now we're going to solve proportions by doing the cross products here, and I get 9x equals 84. Divide by 9, divide by 9. I get 9 and 1/3, or 3 over 9, that simplifies to that. Over here, if we do the cross products, I get 2 times 3 minus t equals 6 times t. Make sure you put the 3 minus t in parentheses. Oftentimes, students will make the mistake of just multiplying the first term by the 2 and forget about the second term, which is going to make it difficult to get the problem correct. So I get 6 equals 8t dividing by the 8. I end up with t equals 3/4. In here I have a picture of a fish, and the photos are proportional, and I want to find the height of the second one. So I'm going to say that 5 is to 7, as 4 is to h. Now, is there more than one way to set up a proportion? Absolutely. I'm going to set up this proportion another way. I'm going to say that 5 is to 4 as 7 is to h is another way to do that. Could we have started with the 4 over 5 instead of the 5 over 4? Certainly, in which case that would change the proportion also. There's many ways to set up a proportion, but as long as you're keeping parts congruent to parts, parts congruent to parts, you're going to be fine. Cross product here, I get 5h equals 28. Dividing by 5 gives me 5.6 inches in this case, I think. Well, I meant it to be inches. We'll make it units because I didn't write it down. Here's the key concept. The dilation about a center C and a positive scale factor is a function that maps a point P in a figure onto its image such that if P and C coincide, that the image and preimage are at the same point. But if P is not at the center of the dilation, then P prime lies on CP. Now, the thing to remember is when we are finding the P, or the C, or the K, my goodness, K, most of the time people get this wrong because the ratio is CP prime to CP. And they're like, well, they see that the whole thing is 10, and so they'll say 6 is to 4. No, 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 no. It's from this starting point both times. So in this case, we have to say 10, the 4 plus 6, all the way over to P prime, is to 4. So my scale factor is 2.5, which they gave us in this case. So oftentimes finding that CP prime over CP is what the question is going to be asking. So in this question, they're saying, what happens if your K is larger? So if I take my C, oh boy, let's see if I can actually get it to hit there. I know, such an So if I take all these lengths from the start here to this, let's say this is length 1, and my k is 2. That means I'm going to have a q prime out here that this and this are the same length. So the total from this starting point C out to q prime is 2. But that doesn't change the fact that q to q prime is still 1. So those would have to be the same. This distance, which from C to P, which is significantly larger than C to Q, but we would double that distance to put it out here. And there's your P prime. The prime indicates that it's the image. The original is called the pre-image, and the image is the one with the prime in it. So here is my S prime, and this distance doubled would be somewhere over here, would be my R prime. And if I go ahead and place some dot to dot with those things, I get something that is similar, but it is significantly larger. Anytime your k is greater than 1, it's going to be an enlargement. And if your k is less than 1, then it's a reduction. So when we're doing enlargements, if my enlargement here is a scale factor, my k is equal to 2, notice that my point P prime is just 2 times the original P. So my P prime is at 4, 6. So you just multiply the x and the y by whatever that k happens to be. In this question, they give us the fact that we have a pre-image, which is the original, there, and we're going to there. So how do I get from -8 to -2? Well, I'm dividing by 4, but you need to have it in multiplication form. So we're going to multiply by 1/4. So my k is 1/4 in this case. And notice that all of the points times 1/4 gives me the image of those. In this case, we have my original is the big one, the blue one, and the green one is the image. See all the little primes on there? So that is the image. So that one would have to be a reduction. To find those points, we need to know the scale factor. In this case, I didn't give the scale factor. I just wanted to make sure that you knew the difference between an enlargement and a reduction. And this one, because the original is bigger, is called a reduction. In this case, all we're doing is saying, oh, how did I get from these points to this points? And obviously my k is 1.5 because it says it. But if my k is 1.5, my c prime is going to be 0, because 0 times anything is 0. 4 times 1.5 gives me 6. And another example, this one is an enlargement because the original is in green and the image is in blue and it's larger. And sketch the pre-image and image of the scale factor of 2. So if I start with -1, 1, there's my A. B is at 2, 2, 2, -2. Oh, go down there. There's my B. And my C is at -1, -2. So there's my C there. And we want it to be a scale factor of 2. So my A prime would be at -2, 2. Right there, and at 4, -4, so it would be over there, and this would be at -2, -4, so there, and it would look like that. All right, that's good enough for section 7.1.